All right, quick question from Friday. Quick question. I got two triangles up on the board, ABC and XYZ. If I wanted to prove these two triangles congruent on Friday, what would I have to do? A lot of work. I'll give you that hint. You had to do a lot of work. If you wanted to show me those two triangles were congruent, tell me some stuff that needed to happen here. If those two triangles were going to be congruent, what did we need to know? Let's start it off here. Matt, what did we need to know? Any two figures, I just picked triangles from Friday. If I want to know two figures are congruent, what do I got to start doing here? Okay, let's look back in your notes. That's how we learn a little bit better. Last Friday's notes, day before this one. If I want to prove two figures congruent, we consistently did what with the sides and what with the angles. We had to prove one pair of sides congruent to the other. We had to prove another pair of sides congruent to another. And we had to prove the third pair of sides congruent to another pair. That still wasn't good enough, was it? I still have to do what up here? These triangles aren't congruent. Not on Friday they weren't. I still have to do what? Let's keep it going. All right, I'm not. Here we go. Angle A congruent to angle X. And I needed to prove B congruent to Y. And I needed to prove C congruent to Z, right? Everyone agree? I had to do 6 different things up there. 6. That was a lot of work. That was a lot of work. And it's the last time we have to do that. There's a lot less I need to show you to prove triangles are congruent. All right, we're going to start it today. To prove triangles are congruent, there's actually 5 different ways I can do it without showing all that work. All right. Again, let me state this again. You do not have to do this anymore. You do not have to show all pairs of sides and all pairs of angles congruent. There's actually 5 different ways we could show a lot less work, and I'm going to show you 2 of them right now. First way you could prove triangles congruent up here. First way is called SSS, which is an abbreviation for side, side, side. Here's what it's saying. If you can prove all 3 pairs of sides are congruent, you can stop and the triangles are congruent. Well, what about the angles? Doesn't matter. Doesn't matter. If you can show me all 3 pairs of sides are equal, the triangles are congruent. Everyone hear that? Side, side, side. If all 3 pairs of sides are congruent, the triangles are congruent. What about the angles? Doesn't matter. Does not matter. As long as you can get me all 3 pairs of sides, you are done. The triangles are automatically congruent. There's method number 1. Here's method number 2. And that's where we're going to stop today. I'm not going to give you all 5 at once. SAS. SAS, which stands for side. What do you think the A stands for? Angle. Side. Now, I want you to notice something. Where's that A placed? Right in between the 2 sides. Does everyone see that? Right in between, because that's where the angle has to be. Look at the pictures over here to the right. That's where the angle has to be. It has to be in between the 2 sides. There is no such thing as side-side angle. If the angle's not in between, guess what? They're not congruent. And there's no such thing as ASS, the donkey theorem. All right? No, sorry, there's nothing along those lines. It's angle has to be in between the 2 sides. If it's not, they're not congruent. I can't stress that enough. The angle has to be in between the 2 sides. Questions? So it's either going to be all 3 pairs of sides, 2 pairs of sides with the angle in between. That's all you have right now. And the triangles are congruent. All right, enough of me talking. Let's start doing this. So what I'm going to do first, I'm going to mark up the diagram. I want to see with you guys if that's good enough to say the triangles are congruent, and if it is, which method, side, 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 or side angle size they're going to be. I'm not going to ask for an answer yet, so don't worry. Madison, what's already marked on my diagram for you? What's already marked? I got a pair of sides. Anything else marked? and a pair of angles. Does everyone see that? I got those marked. A pair of sides and a pair of angles. Good. What you won't see up here is something that you're in charge of marking, because I will never do it for you. And that is a side shared by both of them. Does everyone see a full side in that diagram that counts as a side of one triangle and also a side for the other triangle? Name that side up there. All right, name that side that's shared by both triangles up there. Shoo, where we going? Keating? BD. BD. You're in charge of marking that. I'm never going to mark that for you. I don't usually mark those with hash marks. I mark that reflexive side, the side they share with an X. That's how I roll. If you want to put 2 hash marks on there, go ahead. But you are responsible for that. I am never going to mark that for you. You have to do that yourself. All right, let's take a look. Is this one of the 2 methods that we've talked about? Is it side, side, side? Are all 3 pairs of sides congruent? No. And you're not going to assume AD and DC are, so it's not side, side, side. Let's see. Is it side, angle, side? Well, is the angle in between or not? Where's my? There it is. Let me cover up one of the triangles. Is that congruent angle in between the 2 sides we've marked? Yes, it is. So these 2 triangles are congruent by side, angle, side. What was the directions? Do I have to write a congruent statement? Determine, yep. If so, write a congruent statement. All right. Let me get it back up. Yeah, bring it back up. Okay, so yes. All right, somebody name the one triangle for me any way you want, but the second one matters, as we know. Rand, name that one triangle any way you want. Triangle ABD, thank you. Triangle ABD is congruent to, now match it up correctly. Match up the second triangle correctly so the sides and the angles match up. So if we go ABD, the other triangle's got to be named. Where are we going? Nope. Try again. Got to be named. Lennon? CBD. CBD, good. By. And what method are we using here? I only have 2 to use. Only have 2. What method, Hayden? Yep, and you guys can start abbreviating SAS because that's what we're going to put in our proofs at the end of class. All right, so you don't need to do every single side and every single angle anymore. You can do a lot less. All right, let's go to 2. Is this enough information to say the triangles are congruent? Don't fall in any traps. Just look at what you have. That's all I'm giving you. That's all I'm giving you right there. Is that enough to say the triangles are congruent? T? No. Nope. I'm missing a 3rd side or an angle, aren't I? So don't force. You can't force it, guys, and say, oh, wow, F and J are. You don't know that. You don't know that. Just go by what you're given. Remember, the only thing you can mark is a reflexive side. All right, a side they share. What about 3? 3 going to work for me? Let's see. 3 going to work. Take a look at what I've marked. Is 3 going to work here? Madison, what do you think? Well, what's the only possible thing it could be, Madison? Side, angle, side. But what do you got to know about the angle and side, angle, side? It's got to be where? In between. Is angle N and R in between those 2 sides? Nope. So it's not side, angle, side. So we're not forcing it. Remember, there's no such thing. You should never be writing SSA on your paper. No such thing. The angle's got to be in between. Got to be. All right, let's move on. How about 4? Those 2 triangles congruent. What do we think there? Boom. Matt? Why? Side, side, side. All right, so we're going to write yes. Somebody name that first triangle however you want. Lennon, however you want. Triangle. TSU. TSU, you got it. All right, everyone match them up. If I go TSU, what's the next triangle have to be called? Let's see, make sure I got this. TSU. Okay, I got it. Second triangle's got to be called Jackson. XVW. Let me just write that down, and then let's see, TU matches up with XW, good. SU would need to match up with V. All right, I'm good with it. Bye, Matt. What was the method again?
SSS.
Yep. All right, number 5. Everyone have a right? Everyone sees a right angle. Remember, there's always a right angle right next to it. That's probably never going to be there either. And also, what can I mark on your own here? What can you mark on your own in this diagram? You can mark, let's see, Lennon again. What can I mark on my own? That's congruent to itself. A shared side. Where is it?
YA.
Yeah, hey, this is what I'm saying. I'm not going to do that for you. I'm not going to warn you about it. You got to say, oh, YA counts as a side, so you got to mark it. Do I have enough? Is this enough to say the triangles are congruent or not? Hayden? Nope, don't have another side. Don't have another side. So these are not congruent to each other. Everyone all right? Why? You can't add in. The only thing you're able to mark is a reflexive side. And then what are we looking at for 6? Before I let you go on your own. 6, good enough? What do we think? You only have 2 methods. Rayan, what do you think?
Yes.
Yeah. What method, Rayan?
SAS.
SAS, that right angle is in between, isn't it? Everyone all right? I see a lot of erasing going on. We good here? That right angle is in between. Name one of the triangles for me so we can move. Let's see. Mia, triangle DCE, you got it? So if I go DCE on the other side, DCE, I got to name the second triangle how? Jackson? GFH is good for me. And we already said by side angle side. All right, I'm going to let you do 7, 8, 9 on your own. Before you go on, though, let me talk about 9 real quick. I told you the one thing I'll never mark is a reflexive side, right? That's on you guys. Here's the second thing and last thing I will never mark for review, and it's on number 9. I will never mark vertical angles for you. That is on your own as well. Okay, vertical angles will never be marked by me. So reflexive and vertical angles are all on you guys. You have to mark those on your own. Right? They will never be marked for you. So go ahead, either on your own or in your group, try out 7, 8, 9. See if they're congruent. If you think they are, write me a statement and why. But you have to mark reflexive and vertical angles. Remember, you only have 2 methods, guys. If you don't have all 3 sides or side angle side, it's a big no. It's a big no. And before you even start to determine if there's a reflexive side, mark it. If there's vertical angles, mark it. And if we're struggling, hey, we got to get help because this is only 2 methods. Only 2. Remember, I got 5 total for you by the time we're done with all this. 5 total. This is just 2. All right, most of you guys are moving on to 10, 11, 12. So I'm going to go here. Number 7. Hey, we had MK as reflexive, so hopefully you mark that by yourself. So is this side, 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 or side angle side, or is it neither? Okay, what did we think for 7? What do we think for 7 there? Jesse? Good, great. Side angle side, because that angle is, I cover up one of the triangles, that angle's clearly in the middle. So we'll go, I'm not gonna write a congruent statement because it could have been different than some of yours depending on what triangle you start with. But yes, this is side angle side. Hopefully you marked the reflexive side PR there in number 8. Are those 2 triangles congruent? If so, what method? Where am I going there? Rowan?
Yes.
Yes, what method?
Side, side.
That's side, side, side. Good. And then I told you guys you had to mark the vertical angles, and that's where they were. We got to notice vertical angles. That's on you. Are they congruent or not? And if they are, give me a method. Give me a method. I'll get there in a second. Taylor?
For 8?
9.
9?
I got my vertical angles there.
Yeah. And then you have to proving this.
Is it side, 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 or side angle side, or nothing? That's what we're looking at for number 9.
Oh, side angles. Wait, neither.
Why?
Because the angles aren't, like, the angle is in between
Yeah.
the sides.
Remember, just because you see 2 sides in an angle doesn't mean anything. The angle needs to be in between, which would have been T and V. So this is not possible. Right? 2 sides in an angle don't automatically mean side angle side. All right, if you haven't, some of you guys getting ahead here, which is fine. Give me triangle ABC. I want to make sure you guys are good on what it means to be in between for side angle side. Okay, give me the angle in between side BC and AC. Look at the diagram. Give me the angle in between BC and AC. I just check in to make sure we know, Taylor, what in between means. What's the angle in between BC and AC?
It'd be angle C.
It would be. Good work. So that's angle C. Now, when I ask in 11, what sides include angle B is in between what 2 sides? That's what I'm asking here. Angle B is in between what 2 sides? Angle B is in between. Here we go. Jackson, back to you.
Line AB and line CB.
Okay, AB and BC. AB and BC. What angles include AB? So AB is in between what 2 angles up here? AB is in between what 2 angles? Shoom, there we go. Zoe?
Angle C.
AB is the side in between what 2 angles?
Angle B, angle A.
Angle B and angle A. And finally, which side is included between A and C? So angles A and C, the side in between. Where am I going? T.
AC.
AC. Any questions from you guys before we get into a proof using side, 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 and side angle side? All right, before we start the proof, I just want to make it clear. I know we're doing some problems where it was like not possible as a choice. When you do a proof, that's not an option. Okay, it's a possible. It's got to be done. So when I ask to prove ABC congruent to CDA, we shouldn't have not possible written down. It is going to be possible. We just got to figure it out. All right, everything's marked on your diagram. Everything's written in. You're welcome there. I have AB congruent to DC. That's a pair of sides, right? I gave you a pair of sides. All right, so what I'm going to have you guys start doing to keep track of everything, put a little S in parentheses right next to it. I want you to keep track of what you have here so you can definitely tell what method it is. And then BAC and DCA, that's a pair of angles, so I'm going to have you put an A next to that. You guys already have a pair of sides and a pair of angles, which means to me you have one more pair of something to find. Like probably another pair of sides, right? Because it's going to be side angle side. All right, I got to know where is it? Where is it up there? We know it's got to be another pair of sides for side angle side. Where's it going to be? So that's the only work you have to do here. Where's the pair of sides that are equal to each other on your own here? Let's not start making up stuff, Jayla.
Line AC.
Yep, there it is right there. AC, congruent to AC. And the reason why? How do I know AC and itself are equal to each other, Lennon?
Reflexive.
There you go, reflexive. And we can put an S next to that. Do I have enough or do I need to write more? You got two sides in the angle in between? We're good. And even better news is you don't have to come up with the statement on your own. It's already in the proof statement. Triangle ABC congruent to CDA. And what method did we decide on there? Because there's only two we have today. Rayhan, what's the method?
SAS.
Side angle side, and that's all you guys have to write in your reasons column. I don't need side angle and side written out. Questions there? Got to have all three parts before you write down side angle side. And then last one. All right, I got EF and FG. That's a pair of sides, right? And so is DF and FH. That's a pair of sides. So that tells you you have one more pair. Now, I don't know what it's going to be, side, 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 or it could be side angle side. I don't know in this one. So that's going to be on you guys. Look at the diagram. Where's my other pair come from? Where's my other pair? And you better have a reason to back yourself up. Where's my other pair up there come from? It's got to be a side or an angle, right? I don't know which one, though. All right, what else is true about this diagram? Lennon on fire today, bud.
Is it D, E, and G, H?
Well, what's your reason going to be then? Need something to back yourself up. Specific types of angles we've talked about in that diagram that are opposite each other, that you have to mark on your own, that we marked in this diagram here, number 9. Remember what type of angles I marked up there?
Vertical.
You see any of those type in this diagram?
Yeah.
Yeah, where are they?
DFE and GFH.
Yep. Hey, automatic, right? Automatic. Angle DFE, and you can't call it angle F congruent to angle F. Not going to accept that. Got to name it with 3 letters. DFE congruent to GFH. Definition of vertical angle is not going to cut it either. What do we want to write? Why those two are congruent up there, Keating?
Vertical angles are congruent.
That's what we need. And that gives me a pair of angles. Are those angles in between the sides? Yep. So here you go. Triangle DFE congruent to triangle FHFG. And what's the reason you're going to give me why the triangles are congruent? Ran?
SAS.
Side angle side. That's been all your answers today, right? Side angle side. Guys, that's all you have. That's all you have is side, 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 and side angle side. Master it. Master it right now and tonight because I got to add 2 more to the list tomorrow. 2 more methods.